Welcome back to my YouTube channel Grandpa Mathematics. Today we are going to see how to solve the integration problem by the method of integration by parts. In this method, the integral has two functions. One function we have to integrate into the other function minus integral of integrated function into differentiation of the other function into dx. Okay, let me explain in terms of the example. Here, integral x sin x dx. We have to integrate this. So this is one function, this is another function. You can say first function, second function, like that. So if we differentiate x, that becomes 1, that reduces. But if we differentiate sin x, that will become cos x. Again, if we differentiate cos x, that will become minus sin x. So we should not differentiate sin x here. We have to take x as the other function and we have to differentiate x. So that means when you differentiate x, we have to integrate sin x. If we integrate sin x, what will come? Minus cos x. So minus cos x integrate to one function. So if we integrate sin x, that is minus cos x, into other function. Other function is x here, x. Then minus integral of integrated function. What is the integral value? Minus cos x. So you have to put minus cos x here into differentiation of other function. What is other function we have taken here? X. If we differentiate x, what will come? 1. So it will be 1 dx. So this reduces to the simpler form. So this equal to minus x cos x minus into minus plus integral cos x dx. So this is equal to minus x cos x. If we integrate cos x, what will come? Sin x. So sin x plus cos. Of these two, one function we have to integrate, then into the other function minus integral of integrated function into differentiation of other function into dx. So integral x sin x dx. Here we have taken this as the other function for differentiation, because when you differentiate x, that will become 1, it reduces to the formula, simpler form. Okay, in this integration, x square, integral x square e power x dx, we have to integrate e power x, and x square we have to take as the other function and we have to differentiate that. So if we integrate e power x, what will come? E power x. Integrate one function, so we integrated e power x. E power x is there. Into other function, so x square we return, other function, minus integral of integrated function. What is integrated value? E power x. So e power x into differentiation of the other function, differentiation of x square, that is 2x dx. So this becomes now x square e power x minus 2 times integral x e power x dx. X square e power x minus 2 times. Again we have to integrate this by integration by parts only. So put a bracket. Now again two functions are there. X is one function, e power x is other function. Again here we have to integrate e power x only. If we integrate e power x, e power x into other function. Other function is x minus integral of integrated function, that is e power x only, into differentiation of other function. Differentiation of x is 1 dx. So this is nothing but now x square e power x minus 2x e power x minus 2x e power x, minus into minus plus 2 times integral e power x dx is e power x only plus constant. Now all the term contains e power x, so you can take e power x commonly outside. So this be x square minus 2x plus 2 plus c. So this is the answer. Okay, in integration by parts, out of these two we have to select one person and that we have to integrate into the other function. We have to write as it is minus integral of integrated function. What are the values? The same thing you have to write here. You have to differentiate other function and write here into dx. Here in this problem it is not possible to integrate log x. We can only differentiate log x. It's not possible to integrate log x as such. So that means we have to integrate x only here. If we integrate x, what will come? X square by 2 into second function log x minus integral of integrated function, this one, x square by 2 into differentiation of other function. Differentiation of log x is 1 by x dx. So this is nothing but x square log x by 2 minus 1 by 2 times integral x dx. So 1 by 2 times x square log x minus 1 by 2 times, if we integrate x with respect to x, so dx, integral x dx is x square by 2 plus constant. 2 outside, 1 by 2 x square, if we take outside, then log x minus half plus constant. So this is the answer. Integration by parts, whenever log x is coming or inverse trigonometric function is coming, those functions we can only differentiate. We cannot integrate log x inverse trigonometric functions, so we can only differentiate log x and inverse trigonometric functions. So that means the other function x we have to integrate. To integrate x sin inverse x dx, you have to find the value of this integral. We cannot integrate sin inverse x, so that means we have to integrate x only. If we integrate x, what will come? X square by 2 into other function, that is sin inverse x, minus integral of integrated function x square by 2 into differentiation of other function, that is sin inverse x. If we differentiate sin inverse x, what will come? 1 by square root of 1 minus x square dx. So this is equal to x square sin inverse x by 2 minus 1 by 2 times integral x square by square root of 1 minus x square dx minus 1 by 2 times I suffix 1. See. So that means we have to find the value of this integral and then we can substitute here. So I suffix 1, integration 1 is integral x square by square root of 1 minus x square So to evaluate this integral, we have to make the denominator as a single term. So what trigonometric function we have to substitute for x so that this will become a single term? Put x is sine theta. So this gives dx is cos theta d theta. Therefore 2 becomes I suffix 1 is integral x is sine theta, x square is sine square theta by x is sine theta, x square sine square theta. 1 minus sine square theta is cos square theta. So square root of cos square theta is cos theta into dx is cos theta d theta. Now this reduces to integral sine square theta d theta. So now we have to find the value of integral sine square theta. To find the value of sine square theta, we have to remember this formula. That is cos 2 theta is equal to 1 minus 2 sine square theta. So here we can rewrite this as 2 sine square theta is equal to 1 minus cos 2 theta. So this will be nothing but half times sine square theta, half times integral 1 minus cos 2 theta d theta. Now if you integrate 1 with respect to theta, that will become theta minus, if we integrate cos 2 theta, we will get sine 2 theta. Again this is not theta, 2 theta is there, differentiate 2 theta, 2 will come, that we have written in the denominator, plus constant. Now theta we have to express in terms of x. So sine theta is x. So we will further simplify this. This is equal to half times theta. Sine 2 theta we can write as 2 sine theta cos theta. 2 sine theta cos theta by 2 plus constant. So these two will get cancelled. Now we have taken x is sine theta, so sine theta value will be x. Okay, x is sine theta value will be x. So this gives theta is equal to sine inverse x. Value will be half times sine theta is x, theta is sine inverse x. So sine inverse x minus sine theta is x cos theta. What is cos theta in terms of sine theta? So square root of 1 minus sine square theta is cos theta. So that means cos theta will be square root of 1 minus x square plus constant. Now this value you have to substitute here to get the value of integral. I is integral x sine inverse x is nothing but x square by 2 into sine inverse x minus half times I sub x1. So that means we have tried all these values. Again half times sine inverse x minus x into square root of 1 minus x square plus constant. So x square sine inverse x by 2 minus 1 by 4 sine inverse x minus into minus plus 1 by 4 x into square root of 1 minus x square plus constant. So this is the answer. So we have to integrate integral x sine inverse x dx. So if you put x is sine theta, so this becomes theta. This gets simplified. Let x is sine theta, we get dx is cos theta d theta. Then 1 becomes integral x is sine theta sine inverse of sine theta, that is nothing but theta, into dx is cos theta d theta. So we can multiply and divide by 2, 1 by 2 times integral theta, this becomes 2 sine theta cos theta sine 2 theta. Sine theta cos theta is sine 2 theta. Now integration by parts. Out of this one we have to integrate. So we can integrate sine 2 theta. If we integrate sine 2 theta, what will come? Minus cos 2 theta by 2 into second function theta minus integral of integrated function minus cos 2 theta by 2 into differentiation of other function. If we differentiate theta with respect to theta, we'll get 1 into d theta. So this is nothing but 1 minus 1 by 4 minus 1 by 4 theta cos 2 theta minus into minus plus 1 by 2 times integral cos 2 theta d theta is sin 2 theta by 2 plus constant. Now everything we have to express in terms of x. X is sin theta. What is theta? Sin inverse x. Cos theta, I will write here 1 by 4 cos theta sin inverse x into cos 2 theta we have to express in terms of sin theta, then only you can write in terms of x. So this will be nothing but 1 minus 2 sin square theta plus 1 by 2 times sin 2 theta we can write as 2 sin theta cos theta by 2 plus constant. So this will be minus 1 by 4 times sin inverse x into 1 minus 2 times sin theta is x, so it will be x square plus half times sin theta is x, cos theta is cos theta is the square root of 1 minus sin square theta, so it will be square root of 1 minus x square plus constant. So this is also. So integral x tan inverse x dx. So we have to differentiate tan inverse x because it's not possible to integrate this one. So that means when we have to differentiate only. So that means we'll integrate x. Out of these two functions, one we have to integrate. No? We'll integrate x. That will become x square by 2 into other function tan inverse x minus integral of integrated function x square by 2 differentiation of other function, differentiation of tan inverse x is 1 by 1 plus x square dx. So we can write this as x square by 2 tan inverse x minus 2 will take it outside 1 by 2 times integral x square by x square plus 1 dx. So in this integral, you see the degree of numerator and the denominator both are same. In that case, we can just write the x square, you write this x square plus 1 minus 1. Okay, x square written x square plus 1, x square plus 1 minus 1. So that x square by x plus 1 is there. Now when we divide this x square plus 1 by x square plus 1, that will become 1. And we know how to get the value under dx by x square plus 1. So this is equal to x square by 2 tan inverse x minus 1 by 2 times this portion become integral dx minus into minus plus 1 by 2 times integral dx by x square plus 1. So x square plus 1 by x square plus 1 is 1 minus 1 by 1 plus x square, minus into minus plus comes here. So this is nothing but x square by 2 tan inverse x minus 1 by 2 integral dx is x plus 1 by 2 times this in the form of integral dx by x square plus a square. So 1 by a, so 1 by 1 into tan inverse x by 1, that is plus constant. So this is answer. So in this problem we have to integrate the sin inverse x whole square dx. Again it's not possible to integrate sin inverse x directly, so we have tried this as 1 into sin inverse x whole square like that. Then we can integrate 1. So we can take this one function, this other function. So if we integrate 1, we'll get x into second function sin inverse x whole square minus integral of integrated function x into differentiation of other function. If we differentiate sin inverse x whole square, what will come? This is in the form of x power n. This is x power n. If we differentiate x power n, n into x power n minus 1. So this will be 2 into sin inverse x power 2 minus 1. So it will be 2 times sin inverse x only. Again this is not x. So that means we have to differentiate this further. If we differentiate sin inverse x, we will get 1 by square root of 1 minus x square dx. So this is nothing but x sin inverse x whole square minus 2 times x sin inverse x by square root of 1 minus x square dx. So we will take this as I suffix 1 and we call this as equation 1. So I suffix 1 is integral x sine inverse x by square root of 1 minus x square dx. So how to proceed further? We have to make the denominator as a single term. Once by substituting x is equal to sine theta. So put x is equal to sine theta. This gives what? Dx is cos theta d theta. Therefore 2 becomes I suffix 1 is equal to integral x is sine theta sine inverse x. Sine inverse of sine theta is nothing but theta. Dx is cos theta d theta by x is sine theta, x square is sine square theta, 1 minus sine square theta is cos square theta, square root if we take, they will become cos theta. So it's become cos theta. So this reduces to integral theta sine theta form. How to integrate this now? Now we have to integrate sine theta minus cos theta will come into second function theta minus integral of integrated function minus cos theta into differentiation of this one theta 1 into d theta. So minus theta into cos theta minus into minus plus integral cos theta d theta is sin theta plus constant. Now we have to replace all in terms of x. Okay. So sin theta is x. So theta will be sin inverse x minus sin inverse x. Sin theta is x. Cos theta will be square root of 1 minus x square. Then plus sin theta is x plus constant. So this is the value of integration 1. Substitute this in 1. We get I is equal to, therefore 1 becomes equal to x sin inverse x whole square minus 2 times, because more than 2 terms are there, put a bracket, square root of 1 minus x square into sin inverse x. Of course minus sign is there, so you have to put minus sin inverse x square root of 1 minus x square, then plus x plus constant. So we can write this again, x sin inverse x whole square minus into minus plus 2 times square root of 1 minus x square sin inverse x minus 2x plus constant. So this is the answer.